Alright, so at the beginning of this video, we're just going to go over how to do basic unit conversions. You can probably find better written guides elsewhere, but just if you need a refresher course, this is how you do it. I'm going to start with a basic conversion of converting kilometers to meters. You could just multiply it by 1,000 because there's 1,000 meters in kilometers, but I written it the most consistent way to do it because this is how you should always do it if you want to always reach the right answer. So in this case, you're going to write 1 kilometer and multiply that by 1,000 meters over 1 kilometer. The kilometers cancel, and you end up with 1,000 meters. Obviously, could do that much easily, but that's a very consistent way to get the right answer. Now we're going to convert 2 hours into seconds. Or actually 2 days into seconds. We start off, first need to convert days into hours. Put days on the bottom, 24 hours on the top. Days cancel. Now we have 48 hours when you multiply 2 times 24. Next, we convert hours to minutes, and obviously there's 60 minutes an hour, same thing. Then, again, 60 seconds in 1 minute. Cancel our units, multiply it all together, and we get the number of seconds in 2 days. It's important to note that, as far as I know, normally when you're working with velocities or accelerations, we're working in meters per second, meters, seconds, meters per second squared. So often you're going to need to be able to do conversions between kilometers, days, hours, miles, feet, centimeters. So you're going to want to know those conversions. Here we're going to put kilometers and time together, so we can have 360 kilometers per hour, and we need to convert that to meters per second. Go through, I'm going to start with kilometers. 1 kilometer on the bottom, 1,000 meters on the top. Multiply that. Kilometers cancel. Now you have meters on the top. Now we can convert hours into seconds. Here I use a slight shortcut because I know in 1 hour there's 3,600 seconds. So here I don't have to go through multiple steps. Okay, so in this first problem is if you were driving at 110 kilometers per hour and you look to the side for 2.0 seconds, how far do you travel during this time? Start off and we write distance equals rate times time. That's something you learn at a very young age, and we're going to rewrite this using our physics terminology. So write x equals vt. Now we're going to convert 110 kilometers to hours, kilometers per hour, into meters per second. Same thing as we did in the last step. 1,000 meters over 1 kilometer. And then in 1 hour, 3,600 seconds. Now pay attention, significant figures. We have 2 significant figures in 110 kilometers per hour and 2 significant figures in 2.0 seconds. So when I write the answer, I should write it to 2 sig figs in the end. However, because right now I'm just doing a unit conversion, I want to keep as many digits as possible so my final answer is as precise as possible. So here we get 30.5 meters per second repeating. Plug that back into x equals vt, and we should get 61.1 repeating meters. And then, but because we only have 2 sig figs, in the end there'll be 61 meters. And here I accidentally write meters per second and then erase the second. Going on to the next problem, we have a car accelerates from 13 meters per second to 25 meters per second in 6.0 seconds. What was its acceleration? How far did it travel in this time? So here we're going to start by writing what we do know. And then we're going to, after we know what we know, we're going to solve for the acceleration. We get velocity equals initial velocity plus 8 times t. I'm going to rewrite the equation as v minus v initial equals at. Then put a equals v minus v initial over t. Solving for a, I will get 25 minus 13 over 6. You'll notice we have 2 significant figures in all of our variables, so our answer will be the 2 significant figures. And here we get 2.0 meters per second squared. In our last one, we have a car slows down uniformly from 21 meters per second to 0 meters per second in 6.00 seconds. How far did it travel? Here you'll notice we have three significant figures. First off, we need to calculate the acceleration by saying acceleration is equal to change in velocity over change in time. Here I rewrite change in velocity, change in time as 21 minus 0 over 6 minus 0. Here we'll end up dividing 21 over 6, and we will get 3.5 meters per second squared. Next, we will use the equation v squared equals v initial squared plus 2ax to solve for distance. I will cross out v initial squared because it's just 0. Rewrite the equation as v squared equals 2ax, and then say x equals v squared over 2a. When I plug in my numbers, I will get an answer of 63